welcome to the presentation. The title is Creating a Domain-Specific Language in Kotlin using type-safe builders. So a short introduction. So this seminar is inspired by an article series on Medium by Glenn Sandoval. And if you find this seminar interesting, I encourage you to read it because it's very detailed and very interesting. The outline of the presentation is going to be in, let's say, 4 parts. First, we talk about some concepts of Kotlin that we need. Then I'm going to present a very small and shapes API to draw figures that we're going to build upon in this presentation. Then I talk about the domain-specific languages, and I conclude by doing a live programming session where I implement a DSL on top of the API, of the shapes API. Okay, so let's start with the Kotlin concepts. Let's start with the lambdas. In Kotlin, lambdas are delimited by curly braces. So in this case, we have a print hello lambda, which just prints hello. We can call it like this with normal function call or with dot invoke. If there are parameters in the lambda, we need to put them still in the curly braces and at the beginning with the type and an arrow. The call stays the same, of course, we just pass the parameters. Lambdas themselves, so the function double here, the variable double can be passed as a parameter. So for example, if we do access map double, we create a list of 2, 4, and 6, right? And we can pass the lambdas as parameters by name, so by just passing the name double, or we can also pass the lambda directly inside the parentheses. An important thing is that if a lambda is the last parameter that we have to pass to a function, we can drop the round parentheses, as you can see in the last 2 situations. And if there are other parameters, for example, when we call fold in the last line here, we pass the first parameters in the parentheses, and the last parameter, that is a lambda, we just pass it outside, right? And this is called a trailing lambda syntax. Now let's talk about extension functions. In Kotlin, we can extend a class without having to use inheritance necessarily, or without having to create a decorator. And we do that by just saying declaring a function fun, and we just say string dot or whatever class name dot before the name of the function. In this case here, we are extending the string class with a function that just adds a cow says at the beginning of the string. Inside the body of the extension function, this refers to the instance on which we called the extension function. In the case where we call cow say on the string hello, this is going to be the string hello inside the body of the function. It can be also more useful than adding this cow says. We can, for example, add an extension function liters to the number class, and then we can just say 42.6.liters, and this will create an instance of this class liter. Extension functions are resolved statically, so they don't necessarily play well with inheritance. Just a detail. Function liters with receiver are, let's say, a fusion of lambdas and extension functions. So they're kind of extension functions that we can assign, that we just assign to a variable, right? In this case, is42 inside the body. So again, here is basically the type is no parameters to Boolean, and the receiver type is function. Is a string, right? So we are adding this function. We are creating this function is42 that can be called on a string. And we can just use it like this. We have the string 42, and we can call is42 on it, and it's going to return true. Inside the body of this lambda, this is, again, the instance on which we're calling this is42. And inside the body, for example, for this subtract or multiply functions that we created, we can even not use this, right? We can drop this if we want to, in this case, call minus or times, which are methods of the int class. We can just not use this reference. Okay. The important thing about these function literals with receiver that make them, let's say, more powerful than just extension functions is that we can pass function literal with receiver. We can take a function literal with receiver as a parameter in some function, right? So, for example, we can create type-safe builders, which is more like more like a concept. It's not really a language feature of Kotlin, so it's not really a formalized thing. And they work like this. So let's say we have a class HTML with a method body, which we don't care about. We don't care about implementation, and we want to create a builder for this HTML class. We can create a function called lowercase HTML, and we take as parameter one of these function literals with receiver, right? As you can see, the type is takes no parameter and returns nothing, so it's just a function that just runs. But the receiver is of type HTML, the receiver of this init parameter function. And we see also that this function HTML has to return an instance of HTML. Inside the builder function, we do the following things usually. This is the type-safe builder pattern. We create an instance of HTML, of the class HTML. Then we call the init method on it. And in the end, we return the HTML instance. Or we can also add it to some structure or something like that. You might be wondering, but yeah, what is this useful for? We can then use this HTML function like this. So we call HTML, and in the parameters, we pass this lambda. Inside this lambda, we have access to an instance of HTML, right, of type HTML. This is an HTML instance. So that means that we can call, for example, the body function that we have defined in the class HTML. What is the instance of HTML that we're calling the body method on? It's the one that we created inside in the first step. Is this one here, right? So now again, from what we saw before of lambdas, for the lambdas, we can remove the round parentheses, right? Because it's the last parameter of the function call, and we can also drop the this. So this now, as you can see, becomes very, very idiomatic, right? We just say we create an HTML, and inside it we call the method body. As you can imagine, this can then be nested, and we can create like a tree structure. We can create a builder that has a tree structure or something. Okay, so now let's go to the Shapes API, which is this very simple small API to create rows of color shapes. We can only create circles, triangles, and squares, and we can then add also line breaks between these rows of shapes. We can also create composed shapes by composing two shapes. Okay, so how is this used? We just create an instance of a picture. Then we create a blue circle, a red square. Then we have to add them to the picture. Then we add a line break. Then we add a shape, which is a composed shape of blue circle and red square with the operation difference. So it makes a difference of these two shapes. And in the end, we can just call paint. It's a simple API, so it's a bit verbose. It's annoying. It's not too annoying. But the goal is to then create a DSL to make it more beautiful to use. This is not a real API. It's just been created for this demo. So a note about domain-specific languages, as I also mentioned in the abstract. Domain-specific language, or DSL, is any language that is specialized to be used in some domain. We have some very notable examples like HTML, SQL are domain-specific languages. GraphViz also, it's this DSL to create drawings or graph drawings. Gradle is a DSL also, the dependency manager for Java, Kotlin. Okay, so Kotlin, for the features that we saw before, is very well suited to create this internal something that is called an internal DSL. So what is really an internal DSL? So yeah, DSLs can be separated into two categories, which are external DSLs and internal DSLs. External DSLs have their own custom syntax. You need to write a parser to interpret the DSL or to translate it into some other compiled language that then you can run. And there is a strong tradition in the Unix community to create these external DSLs. Instead, internal DSLs are built on top of a host language. So in our case, it's going to be Kotlin. They exploit language features, syntactic sugar, and many things to create to give the impression of that you are using a different language. But in the end, you're really just using the host language. Like in our case, it's going to be Kotlin. There's been a long tradition in Lisp for these internal DSLs. But they have been re-energized or repopularized by Ruby, and now also by Kotlin and Scala. Okay, so let's get to the shapes DSL. So the DSL that we build on the API that I showed briefly before. So we're going to have a type-safe builder for a picture. Inside it, now we have an instance of picture, so we can create shapes, so a circle with this size and color, a square. We assign them also to variables. Then we can just call a function to add a line break in the picture. And then we can also create composed pictures. And instead of just saying difference, right, we can just use minus. And we're going to see how to do this in Kotlin. And in the end, we can just call paint. So now let's go to the implementation part. So yeah, here now you can see this is the API. We're using the API. We create 4 shapes. We add them. We add a line break. We create a list of sizes, and then we just add these 5 circles, then another line break, and then we add a few composed shapes. This is going to be saved in this picture API.png. So if we run it, it's going to run, okay, and it's going to create this picture here. Okay, so the 4 shapes, the 5 circles of increasing the radius, and the composed pictures in the bottom here. This one is the composition of these 2 squares, for example. Okay, so going to the DSL. Now I commented it because, of course, we didn't implement it yet, so it doesn't compile. In fact, if I take it like this, this says unresolved reference. Also, picture doesn't really exist. This is what we want to get, basically. This is going to be the same code that does the same thing as this. Now, to start, let's just take again the same exact code that we had in the API. Yeah, in fact, it's going to say that it's a duplicated code fragment, of course, because it's going to be the same thing. In the end here, we're going to print it into another file. So let's start. We need to create a picture. And we're going to do it like this. It's going to be this thing like this, right? And inside it, we're not going to have the picture instance, but we're going to use this, right? So if you go like this, this dot at shape. But as we saw, we can also just remove this. We can just drop. So let's create this picture function. All right. Let's create a new package, DSL. And let's create a Kotlin file, which we call extensions. Maybe that's typo, I don't know. Okay. So we create a function picture. It will take an initializer. An initializer, which is a function type with receiver, which will be called on an instance of picture. And picture has to return a picture, right? Because at the end here, we call a dot paint on it. Okay, so what does this do? It creates a picture, an empty picture. It calls init on it and then returns it. Okay. Now here it still doesn't work because we have to import it, and let's just import everything from it, so it's gonna be easier. All right, so now this works. This, as we can see, the event tells us this is gonna be a picture. So add the shape is gonna be the method of the picture class. Now for this part here, now we have to create, as we saw before, the same thing again, but it's gonna be called circle, right? Size is going to be 100, color is going to be green. Now, of course, this doesn't work at all for now. So let's go again to the extensions. And we say, we create a function, but what should we be able to call it on? We should be able to call it inside here. So let's just say that we call it on the picture instance, right? So we add this picture.circle. Inside it, we need an initialization method again. We need, it's going to be, let's say, circle unit, and returns a circle. However, now we see that, if we import this class, yeah, if we see the circle, it's like we don't really want to touch this circle class, because it's part of the API, so we don't really want to modify the internals. So let's add a new package. We create a package for the builders. We create this circle builder. Inside it, it's going to be super simple, super mutable also. The size by default is going to be 0. Color is going to be color.black. Build, the function build, so this is a pretty normal builder. Build is going to return a circle, and it's going to be size and color, right? So now here, instead of having an initialization method on a circle, we use a circle builder. Okay. So what do? We create a builder, an empty builder. Is going to have all the default values for the fields. But what we can do is we can call the init method on it, and the init method is going to assign a size and assign color. Inside here we have a circle builder. We are just reassigning the values of the fields, right? These are just the fields. Okay. We create now the circle by just calling build on the builder. Now we can return a circle. But actually, let's say we also want to add it to the shape automatically. We create it and we add it immediately to the picture, sorry. So what we can do is we can do this dot add shape of the circle, right? This is the add shape method of picture. So now if you go back here, we don't even need to add it here at the end. Now for the square and the triangle, it's exactly the same thing, okay? So I'm gonna cheat a bit here. I'm gonna just check out yeah, let me just do this. Okay. Okay. Yeah. I have to remove what I just did. Let me just remove everything. Okay. Okay, so now it's the same thing, right? The square also has the same thing, also use a square builder, the triangle builder uses the same. And we have these two more extension functions which do exactly the same thing. Okay, one detail in the builders here, since they do basically the same thing, they have the same properties, we abstracted out the two fields, and the function build is abstract, and we extend it in the three builders, square builder and triangle builder. Okay. Okay, now we have this add line break, which we don't really like it that much. We would like to just do line break, right? So let's just add it. Right, this doesn't do anything. We just say this dot add line break. So now we can just say line break. Okay, here in this we use the size, these sizes, we create circles. What we can just do is we can just say circle size equals it. So it actually is just the default name of the parameter, but we can just call it n. The default name of the parameter for each. We don't even have to assign the color here because actually by default it's black. We know it, so we don't do it. Now let's get to the composed shapes. So to create a composed shape, let's say an instance of a composed shape, let's do this. Let's do an extension function for shape, and let's do union. Okay. And this returns a composed shape. We want a way to create composed shapes. So what does this do? Just creates a composed shapes with this, which is the shape on which we call the method union order. And since it's an union, we just say operation.union, which is the same thing that we were using here, right? Now we're able to do this. So we can do this here. Instead of composed shape, we can say red square dot union, what was it, blue square, right? We don't really like using dot here. So what we can do, this is a feature of Kotlin, we can just say infix function instead of just function. So now what we can do, we can just omit the dot and the parentheses. And another thing that we can do is instead of using union, we can create now an operator function. Again, it's an extension function of shape. An operator function allows us to override like plus and minus. How do we do it? We just have to redefine this this method, this plus method. It does the same thing, returns a composed shape, and in fact, we just reuse the function we defined above here. For the difference, we can just do the same exact thing. So I use the difference, and we use minus for the difference. So now here in the shapes, red square union blue square, this can become a plus actually, right? This is also a plus. This is going to be a minus. And here we have it nested because that's how we needed to use it for the API, because the API only has the composed shape only has two shapes inside it, right? But what we can do now, since we are using operators, infix operators, we can just do this. You may be thinking, how can we instead, because this is going to do a union of this, and then it's going to do a subtraction of this. If we want to do the opposite, we can just add parentheses like this. Okay, now the only thing missing is a way to say that we want to add a composed shape instead of having to call this add shape method. So what we can do is we can do again another extension function composed. So now this is going to be a bit different than usual. We don't really need a function type with receiver. We can actually just take a simple lambda, right? A lambda that returns us a composed shape. And this, we don't really need to return it, the composed shape, but for consistency, let's return it, like for the builders, for the triangles and so on. So here, what do? Let's call this lambda that creates a composed shape. So this can also be called build, okay, or whatever. We can call it however we want. Now we are in the picture, so what we can do is we can add the composed shape directly, and then we can return the composed shape. So what we have now is here we can just say composed, and in the end what this does is really just the compose function runs this lambda, right, and adds the results to the picture. And we can keep doing it for the other two. And we reached the end, except that, yes, let me see this thing here. Okay, so now we reached the final, let's say, version of our DSL. And if you run it here, in fact, we don't even need all these imports here. If you now run it, okay, so this actually uses the default name of the file, which is going to be picture. Let's do it. Let's do it nicer. Okay. We have the picture DSL, which is exactly the same that was returned by the API before. Okay, now we're done with the implementation part. And I have a few notes missing. I'm a bit over time. I just wanted to show some short examples of real Kotlin DSLs. So we have KTOR, which is this DSL to create servers and map like handlers to routes, and it's nested, as you can see. Then we have this Kotlin X HTML, which is an HTML to create it's a DSL to create HTML. Okay. Right, and you can see it looks a bit like JavaScript code, this Windows set interval. Then we have Gradle, the Kotlin version, because the normal or older version, I guess, was just Groovy, which has also this type safe builder feature, I think. They also have this thing. So in fact, all of these plugins, these are all builders. And then if you're Eric Meyer, you can also exploit Kotlin and operator functions and non-ASCII characters to create things like this, which I have no idea what they are, what it means. But yeah, you can do pretty cool stuff. Thank you for listening. And yeah, this was the presentation.
Thank you very much.